Hi, my name is Rodolfo and I will make an introduction to the theory of interaction. To understand interaction, we first need to understand what a system is. A system is a group of parts that work together with some purpose. We will use the word system, entity, and being as synonyms because they are the same from the point of view of interaction. And we will use the acronym SS for systems and uh, IX for interactions. It's something to be noticed here before starting. Systems can be closed or can be open. Closed systems do not interact with the environment. That means they don't accept inputs or generate outputs to other systems or the environment. Open systems, on the other hand, are able to accept inputs and generate outputs for other systems or the environment. Open systems have the capability of acting and reacting. Acting means generating stimulus for other systems. The fact of answering other systems' stimulus is reacting. The capability of reacting is very important for open systems, as it is the mean to keep stability. A bee, for example, reacts with aggressivity if it understands that the colony is in danger. If you hit a football with your foot, the ball reacts by absorbing the impact and causing a deformation. Afterwards, the energy transmitted by the impact is converted into kinetic energy. It's a complex process we will not analyze here, but in synthesis, the ball reacts, turning the impact energy into kinetic energy and moves. A rock acts exactly in the same way, but the deformation is not so obvious. It's not visible. If bees, footballs, or rocks don't produce a proper reaction to stimulus, they can get destroyed. They can dissipate. Even the smaller finger touch to a rock that has not the capability of reacting and causing deformation, even the small contact will cause the rock to disintegrate, the ball to explode. It will cause the bee colony to be invaded and dissipate. Systems have not only the capability of reaction, they can also generate active stimulus. They can create actions. For example, a bee's colony normally take the initiative to gather food, that is, sending bees to explore the environment and gather food. So, we draw systems as black boxes. We don't need normally to know how subsystems work. We are just concerned with the system and the supersystem scale. Anything above or below is not of our interest. To analyze colonies of bees, for example, we don't need to understand how a bee works. We don't need to know its anatomy, physiology, its inner systems, how it breathes, how the digestive system works, etc. We just need to observe the natural entity, the bee, the rock, a plant, a tree. Let's use a tree. For example, a tree accepts CO2 as an input. It's something that we all know, and it's able to generate oxygen as an output. When we use the systemic approach, if we use the general systems theory, we need to know all the inputs and outputs of the system. In this case, the inputs can be sunlight, water, minerals, etc. Outputs can be water, organic matter, food fruits as food for other animals, etc. This is important on the systemic view of entities. But as we are going to analyze interaction, we don't really need to know how to know other inputs and outputs. We can neglect additional inputs and outputs. We can focus on just isolated dimensions. For example, a tree can be understood as a converter of CO2 into O2. A cow can be understood as an entity that converts some pasture into milk. From the interactional point of view, we are not we don't need to know how does a cow does that, how does it convert pasture into milk, what other things it requires to convert pasture into milk. We are not interested in the other resources that a tree uses to convert carbon dioxide into oxygen. I will explain this in an instant. Observing a system, in this case a tree as a whole, is it's useful for analysis, for understanding how does it operates, for understanding how it behaves as a whole, how does it connect to the other systems, how does it integrate, what are its relations. In fact, the systems theory main approach is related to entities and relations. But this approach is only an idealization of systems. Moreover, we can say this is an humanization of natural systems, an objectivization. A system has a different meaning for nature, for the rest of natural entities, for other entities. For example, what does a tree means for an animal? We will draw how does an animal interacts with the tree. Basically, this is how animals and trees interact. Animals produce carbon dioxide that trees consume, and trees produce oxygen that animals consume. In other words, for an animal, a tree is just an air converter. A tree is just a converter of CO2 into oxygen. That's it. Animals are not concerned with sunlight, the photosynthesis process, the minerals that the tree requires to absorb, even the size of the tree. For animals, trees are entities that convert useless CO2 into O2. Animals have a subjective view of trees, as we have other subjective views of trees. For us, for example, trees can mean an ornamental object. For birds, a tree is a protection to ground predators. For dogs, a tree can mean a referential point to mark territory. We can say that natural entities understand other entities subjectively, and this is not only for living beings. All natural entities work like this. They don't read books and learn the systems theory. They just have some properties built inside that allows interaction by means of the internal capabilities. For example, water can mean destruction for a salt pebble, and the same water can mean a source of minerals, therefore solidification, not destruction, for a rock that allows water to pass through its pores. That is the reason we are not interested on other inputs or outputs on the interaction theory. From the interactional point of view, the systems theory provides an objective point of view, and this is good for learning, for scientists, for knowledge, at last for humans. But this is not useful for natural entities. Natural entities have a subjective understanding of systems. This, combined with the capability of systemic action and reaction, causes natural systems to interact in huge, enormous, almost infinite ways. How many systems have you, as a person, interacted with along your life? Think on it. Machines, animals, natural elements, objects, non-living or living, direct energy, complex feelings, etc. The list can be infinite. Of course, this is a completely abstract idea. There is no consciousness about the meaning or about dimension for natural entities. But this is how systems interact in nature. This is how entities communicate in nature. Entities act like dimensional transformers. Does dimensional mean? What's a dimension? In fact, this is something that will be analyzed in further videos. For now, let's say that systems transform contents in one dimension to other dimensions. For example, a spring is able to convert kinetic energy into potential energy. Therefore, our human, rational, mathematical approach of a system, the general system theory, is completely different to the approach of a natural entity. From other natural entities, that is, it's different. This is what the theory of interaction describes. This is in essence what interaction is about. Basically, interaction is an exchange of contents between two entities. The values of the contents are absolutely subjective. When you buy something, the value you pay to the you're paying is completely different than the value the seller has about the money you pay and about the thing he is selling. The theory of interaction, we will provide the acronym TOI to the theory of interaction. I would say that the theory of interaction is the natural approach of systems. The natural approach of systems. The general systems theory, we will use GST to the systems theory or general systems theory as it's called, despite the word general is not really appropriate. The general systems theory is the rational approach of systems. Let's see some differences. The general systems theory is the rational approach of systems. It is a global and comprehensive understanding of systems. It's only possible by using reason and mathematics. On the contrary, the theory of interaction is the natural approach of systems. It is a segmented understanding of systems. It's not the complete understand of a system. It's not the plane. It's not the design, the structure of a system. It's just a segmented, subjective understanding of systems. It is the approach of natural systems from the point of view of other natural systems, rocks, animal herds, colonies, atoms, whatever other systems in nature. The GST is the objective approach of systems. It's only possible from a human point of view. Since we as humans are curious, we try to understand everything, to agree, to be objective. We try to measure, calculate, integrate, to find relations, etc. But over all the dimensions of a system, that is not useful for nature. Nature doesn't work like this. For nature, the theory of interaction is it's the subjective approach of systems. Not for nature, but the theory of interaction is the subjective approach of systems, an approach of a system from other entities. As we said, a tree has a subjective value for animals. A woman has a subjective value for a man. It can be understood as a loving partner, for example. But a lion could have a different subjective point of view of a woman. A lion can understand the same woman as food. If she has a newborn, the newborn can understand her also as a source of food, but in another way. Natural entities have always a subjective understanding of other systems. Um, the general systems theory requires to observe systems as closed systems to allow their analysis. Yes, it seems that the systems theory will approach all types of systems, but the systemic approach, the general systems theory approach, reduces the approach to limited systems of dimensions and excludes other dimensions. For example, a free fall requires to be analyzed as an interaction of few variables: position, time, maybe friction and wind speed, but no more. Otherwise, the analysis gets complex. The free fall cannot include all the natural elements: texture, material, time of the day, predators near, an occasional storm, a lightning. Yes, the probability is minimum, but excluding all the elements with small probabilities is just converting an open system into a closed system. On the other hand, the theory of interaction requires to observe systems as open to allow analysis. For example, as we know, there is a property of open systems that is called sensitivity to initial conditions. So when we can understand multiple simple interactions to understand why does the flapping of a butterfly in India can cause a storm in Canada 3 months later. All interactions can be considered, even a storm or a lighting, under the view of the theory of interaction, because they are just other types of interaction. A system may develop by interacting with other systems that act as food source, but it can get destroyed by lightnings. The interactional point of view allows a separation of interactions without excluding the open system's behavior. The general systems theory focuses its analysis on one system and all its features, the whole dimensional set. For example, we may observe a tree, so we will observe all features from the tree. We may observe the supra and subsystems, but as soon as we include more and more layers, the analysis becomes complex. So the best focus of the systems theory is always with one system. The theory of interaction, on the other hand, focuses basically two systems interacting in a dimensional subset, not the whole set, only the dimensions that matter on the actual interaction. We will not observe the whole tree, but we will observe the actual profit of the tree when interacting with animals. But now, observing couples, the analysis becomes fractal, not scalar. Therefore, we may analyze the interactions that are important for our study to see that high fractal level entities are built with other smaller fractal size entities until arriving to the fundamental level, atomic particles, quantums, strings, etc. On the other direction, we can observe how the system belongs and interacts with higher scales of existence, the organization, the group, the environment, the universe, etc. The theory is clear about horizontal interactions or interactions of couples on the same level of existence, and vertical interactions with the suprasystem or the subsystem. We can say that the general systems theory focuses on the structure and the theory of interactions on the performance. The systems theory is like a picture of a system, and the theory of interaction can be compared with a scene of the whole system movie. The general systems theory focuses on the state. The theory of interaction focuses on change. In fact, this is the current academic approach of systems, the focusing on a state that prevents the analysis of change. But the theory of interaction focuses specifically on change. Yesterday, you went to coffee and you paid $2. But that interaction produced an excellent final result on you. You've made a friend. That's a positive interaction. Of course, that doesn't always happen. Sometimes we can go to coffees and suffer the bad music, the bad coffee, etc. A last one. As the general systems theory focuses on all inputs and outputs, it's clear that what comes in should come out. Of course, this is only possible at the energy level. In other words, on the general systems theory, the sum of inputs of systems must be equal to the sum of outputs. Of course, plus the energy that gets stored on the system. We should add this here. This is called linear behavior. But on the other hand, on the theory of interaction, what goes in on an interaction is always different to what goes out. Therefore, when we consider an entity as a transformer, if the input content has one value and the output content has another value, either the difference is incorporated to the system, what will cause the development of the system, or either it is temporarily stored, what can be observed as a temporary buffering. But always the interaction causes a different input and a different output to a different input. In fact, interactions that prove the same result are stupid for nature. If I go to the market to change $1 for an identical dollar, I don't mean a different coin. I mean for an identical $1, I've just spent useless energy. This is called non-linear behavior. On the theory of interactions have not a balance. The behavior of the interaction is in essence non-linear. So we can get some conclusions as features of interaction. First, Interaction is the language of nature. Natural entities communicate between them only by interacting. Not only entities on the same scale of existence, but any entity on any scale of existence may interact with any other. Mathematics has always tried to imitate interaction, but as mathematical systems are closed, this is not possible. Observe this equation. X equals y. This means that x can be converted to y and vice versa. Y can be converted to a value on the x dimension. This is bidirectional, a fact that doesn't exist, that is not possible in nature. Well, in some systems maybe, but generally it's not normal in nature. A cow, for example, may transform pasture into milk, but it can't transform milk into pasture. This is not possible at all in nature, but in mathematics it is possible. In fact, it is required to allow the systemic view to find a linear behavior. Um, it's important to mention that here we have the clear presence when of the time row when interactions become have a direction. Then for an entity from the subjective point of view of any entity on the interaction, there is a time row that is related to the interaction. That is not the same on the theory of systems. The theory of systems has an approach of permanence, of persistence, of infinite. Anyway, uh, some facts that we are going to learn in further videos is that interaction provides order to the interaction partner. Order is a dimensional disposition that is present during interaction. For example, atoms in a molecule of water have a perfect dimensional disposition. That means position. The dimensional dispositions is related to the dimension of position. As long as they belong to a molecule of water, of course. When two persons speak one in front of the other, they have a dimensional disposition. They require to get into a dimensional disposition to be able to speak. They should position at about 1 meter of distance, for example, have no obstacles in the middle, use the air as a carrier. They can't speak underwater. If they interact in another dimension, for example, if they communicate through a mobile phone, the dimensional disposition is different. They don't require to be at 1 meter of distance. They can be in different places of the world, but now they require to have access to a phone network, to a phone. Order is related to interaction, as we said. Interaction generates order. We will also learn that chaos is the lack of interaction. If a molecule of water is broken, atoms will not keep the same order. They will enter in a positional chaos. They can keep order in other dimensions. For example, they can keep kinetic or potential energy, but they enter in a positional chaos. The dimension of position acquires chaos. Another interesting fact of interaction is that interaction provides existence to systems, not only order but existence to systems on the scale of interaction and the upper scales. For example, two atoms of hydrogen and one atom of oxygen interacting on a precise disposition provide existence to a molecule of water. A man and a woman interacting continuously provide existence to a love couple, a marriage, to a bigger system. But this is only possible when they interact following certain principles described in the theory of interaction. The theory of interaction defines the criteria that causes interactions to be positive or negative for each interactor. A positive interaction, therefore, may cause an entity to remain on the supersystem or not. For example, an animal, an elephant, let's say a monkey that performs positive interactions with the troop, I mean positive for the troop and positive for the monkey, may continue pertaining to the group. If it performs interactions that result negative for him or the troop, it will cause the monkey to be separated from the troop, to acquire chaos on the pertinence dimension. If you are an employee that interacts positively with the factory you work in, I mean, you interact positively with people, you're nice, you're helpful, you teach, you learn, etc. You interact positively not only with people but with machines. You take care of them, you do not break them, you use them properly, then probably you will continue working on that factory. Moreover, you can get promoted. If you hold interactions that cause negative results, either for you or the factory, you will get fired. That's for sure. If you're a buyer or a seller working in a market and you do interactions that provide positive results to the market, you will continue to be allowed working and interacting with other subsystems on the market. And you can even increase the number and quality of interactions. If you don't, you will be excluded from the market. In fact, if you are a common citizen in Europe, where countries are suffering an economic crisis, we put here economic system. The sorry. Then, if you hold positive interactions with people, supermarkets, with the other economic subsystems, you will be encouraged by nature to interact with the other systems. But this is not the case in Europe, due to a lot of problems like corruption, bad laws, bad national education, education focused on money, and other bad sources of interaction. The European set of entities on the economic at the economic level, the economic subsystems have started to reduce interactions. For people, it's not nice to buy things. Things are expensive and they continue to lose quality. That is a direct effect of the focus on money that governments, schools, and universities teach. Therefore, the European economic subsystems, people, stores, commerces, all the economic subsystems have started to reduce interaction, to reduce the number of interactions. That is why this is just nature generating chaos, looking for the dissipation of the system in order to reorganize the subsystems in a different manner. People, companies may want try to interact, but it's difficult. That is the consequence of being excluded of the market, the consequence of companies trying to squeeze money from the consumers. Consumers just stop interacting. That is a crisis. That means destruction for everything. That is what Europe has lived in for the last years. This is maybe the most painful example. If humans interact with the planet and provide positive results to it, the planet will react in a way that will cause more interactions. The planet will naturally encourage us to interact with it. Sadly, this is not the case. As we are destroying the planet, it's clear that we are doing something wrong, that we are causing a rejection to the planet. We are interacting bad with the rest of subsystems. So, in consequence, nature is trying to expel us from the planet. Some thousands of years after humans get expelled from the planet, nature will regain stability and continue the path of evolution. So, the interaction principles can be learned and applied consciously. In fact, many people, companies, governments have started applying them without actually knowing them. This is why it's very important to study and learn interaction, to learn the principles of interaction, the theory of interactions. In fact, the only thing that humans need to reduce the environmental impact, to reduce crisis, to reduce social issues and most problems is just to interact as nature does. We need to imitate nature. We need to learn how does natural systems interact, and we need to imitate that behavior. That's it. So, in the next videos, we will start analyzing the principles of interactions and to knowing more about interaction. But first, we require some conceptual definitions, mainly of dimensionality, chaos, order, etc. So, see you there.